Ready to go. Thank you. Thank you again, guys. Brandon, Belkis, Lorena, the production team. This is great. Miruna, James, thank you for your patience. Um, we are ready to go. We're ready to go. We're excited. We are in the response. Welcome, everyone. We have a very, very interesting panel. We have an interesting topic. We're going to be talking about explain banking and fraud, moral risks and controls, explained with an AI capital. So you know that is related to artificial intelligence. And I have great two guests to the podcast that are going to be with us for the next hour. I met them through academics. They were my teachers at some point, so I'm learning from the best, and I want to share their knowledge with you guys. So we have today with us Miruna Clinshu, a PhD candidate at Edinburgh Center of Robotics, and she's also an AI risk and strategy consultant with Mijares Consulting. So we're very lucky to have somebody like her with us joining the team and helping our clients. And we also have James Githard, Senior AA ML Engineer with Wells Fargo, also CEO, founder of Githard Analytics, LLC, which is a boutique firm for AI and anything related to ML and LLMs. So the good stuff that are coming on to the market in artificial intelligence. So I'm going to let them introduce themselves a little bit more, and then we will proceed with the disclaimer. We need to have the legal disclaimer, and then we'll have a very, very nice conversation with these guys that have a lot of knowledge to share. So ladies first. So Miruna, if you can introduce yourself to the audience, that would be great.
Hi everyone, so my name is Miruna Clinciu. I am a PhD student in the field of explainable AI. I'm affiliated with Edinburgh Robotics Centre, Scotland, UK, and this is a joint degree actually between University of Edinburgh and Heriot-Watt University. In the last year, I focused a lot on models, mainly large language models that are trying to generate natural language explanations. Also, I was very interested in the research field like common sense, evaluation metrics for natural language generation text as well. And in the last years, I also done a lot of teaching. I love to actually teach courses related to artificial intelligence, business AI products, AI strategy, and quite recently also how we could digitalize the healthcare industry through using, of course, AI systems as well. So that's my little introduction. James?
Thank you, Miruna. Yeah, James, your turn, man.
Sure thing. So, hey guys, my name is James Gearhart. I'm out of Columbus, Ohio. Academically, my background is economics, philosophy, and data science. I currently are in the financial services industry. I primarily work in the AI Center of Excellence for consumer lending. So there's lots of marketing models and risk models and underwriting models, things like that, even logistics. Before that, so I've been in financial services for the last dozen years. Before that, I was in government services. So anywhere that there's a company too big to fail, that's probably where you're going to find me.
James, thank you, Miruna. Appreciate it. So, James, let's start. Let me ask you something, man. We need to start with
Sure.
one of your suggestions. So, when is AI taking over humanity? When are we going to be doomed?
You know what? If I believed that every time I opened up, my apps or anything like that, you'd think it's already happening. Every time I open up an app, there's a picture of the Terminator on there with the headline of "When will AI destroy us?" Not if. At this point, it's a foregone conclusion. It's when is it going to happen, so I can plan my day around it, kind of thing. But all jokes aside, AI, it basically already has in many aspects taken over our world. Can you imagine not having spell check, something like that? If I didn't have spell check, I think I'd be fired right away because they think this guy is an idiot who can't spell his own name, really. What about if we didn't have a spam filter, something like that? Can you imagine if just like everything flooded your inbox, or if Netflix didn't have recommendations, if instead you went there and there's just an alphabetized list of all the movies they have, you wouldn't be able to find anything. So we like the convenience of AI when we find it very beneficial. And that's what we've really been working on, integrating it in people's lives to make things better. However, we're at that, inflection point now of, AI systems look like they might be able to do my job. Now, wait a second. Now suddenly I'm pushing back on AI. So it is an issue more about alignment, really. When I think about, is AI going to destroy us? I think about these AI companies. They're sinking, what do we estimate, like $1 trillion into the development of these things over the next, year or two and stuff. So they're building these massive data centers that have to be powered by the sun or something, and you have to cool it with the ocean. So these are incredibly massive, very expensive systems to build. They're going to have to get that return on investment somehow, and that's the real concern that I have. It's the misalignment between incentives here. I view it more like pollution than anything. So industries that they obviously want to turn a profit, but they have this unnecessary byproduct, of their manufacturing process, which results in pollution. For AI, that pollution could be like poor mental health. It could be job displacement. It could be lots of different things, and actually like real pollution, because like I said, it takes a lot of energy to power these things. It takes a lot of, water to cool down these systems stuff. So there are both, physical and non-physical pollution that's being created from these AI systems. So if the question is, when is AI taking over the world? Hopefully, not in a literal sense, although, we can't be too sure about that. We want to have AI more as a co-pilot. So I'm in control and it's doing what I want it to do, kind of thing like that. But as these systems get larger and more advanced, you have these agentic, components now that could do multiple tasks without any kind of supervision. We're going into uncharted territory. So the only thing we can, do is try to align these systems with safety. But again, like when you have that much investment out there that they're going to need to recoup at some point, my biggest concern is how they're going to make that money back safely across the public. So, and that's to be seen.
Thank you, James, and you're right, man. If we add on top of that, when quantum computing comes to play, energy consumption is gonna go up crazy. So before we keep going, let me read the disclaimer, so we're all safe here. So the views shared in this podcast are those of the speakers alone and don't represent any organization they might be connected to. Everything discussed is for informational purposes only, based on personal experience and perspective. Okay, so now we're good. Now we can keep talking about how when AI is taking over the world. So James and Miruna, you guys are in academic also and industry. So you are, let me ask you, and let's start with Miruna, but this question is for both of you. What would be the main difference and similarities between artificial intelligence in academics and AI in the real world, in the industry?
So I believe that both academic artificial intelligence and the real life AI will represent actually different stages of a single technology lifecycle. Now, if we think what's different, right? We definitely have different goals and also different metrics, and this will make a major difference from the academic AI to the real world AI, real life AI. Now, in academia, we have as a primary goal our way to actually push the boundaries of knowledge. We try to learn as much as possible, try to create novel models, new theories, try to achieve that state-of-the-art results. And also we have our own standardized benchmarks, which also will give us that higher accuracy on a specific task. If it's image or image recognition datasets, we have that specific benchmarks. James spoke a bit about large language models. We have specific benchmarks for large language models as well. And we try to use that as our standardization, so our guidelines. And of course, the success metric now might be maybe if we publish a paper in a well-known, in a top-tier journal, in a top-tier conference, and we won't have maybe clear application in our mind, an immediate application of these methods in our mind. But of course, then we have the real world AI. So now they have a different goal to solve actually business problems, user problems. And here this can be so different, right? From one company to another, from one AI product to another. It can be maybe a chatbot that will try to optimize maybe the supply chain, or it can be some company customer service. And again, we need to think about different success metrics as well. So it can be efficiency, scalability, cost effectiveness, user satisfaction, because I spoke about our users as well. So clearly, we don't have the same scenarios. They are very different. But something extremely important are also the constraints and the resources. They are very different. If you are lucky in academia, maybe your university is having a massive computational resources, or maybe you are sponsored by large tech companies, and then you are able to train your models on huge amount of data for weeks, months, and you don't have that immediate constraint, budget constraints. But if we think about the real life AI, you do have so many constraints. You need to be fast, efficient. Of course, the AI application might be on a smartphone or on a web application. You might have a web server. So again, you need to think how you could run all these AI applications and also the hardware that you will use. You can also cope with messy data, missing data, biased data, and how you could create that in a more robust way. So you have strict budgets, strict timelines. You will also need to ensure that your system will be actually maintainable and you can update it. So it's very, very different. We have so many differences. What will be the same thing? Maybe the core fundamentals. Both of us, right? We are using the same machine learning models, simple or more complex deep learning, neural networks, decision trees, large language models, and everyone is relying on data. For both academia and the real world environment, we need good quality and quantity data in order to have good performance. So it's very interesting, right? But we have also core problem. We have this problem of bias, and we will need to actually identify how we could solve the bias problem in both academia and the real world industry. This can lead to inaccurate conclusions for the real world applications, unfair outcomes. And in the bank domain, right, it's very, very difficult because maybe we need to think here about loan applications or even hiring someone. We do need to have fair decisions. Yeah, and I think that's my point of view.
That's very interesting, Miruna. Thank you. Because yes, between the resources that the academic has and the constraints that the real life has, there's interesting how AI really affect both industries or both areas. So, to you, James, what would be the difference and what would be similar for academic and real life?
It's funny when I think about academic, AI, I remember like learning techniques, in school, and I kind of didn't believe it at the time because if you're learning clustering, say, usually they give you like the iris data set, its famous data set, and all the clusters are nice and tight and it looks great. But when you try to take this technique and apply it to the real world, the clusters never look nice and tight and beautiful like that and stuff. So there is like kind of I wouldn't say deception, but there's a difference between when you learn things, academically, and then when you go to apply it in the real world with messy data, it's not going to kind of look the same. Same thing with even like a simple regression model. If you learn that in school, they're probably going to use like this real estate database that has this nice linear trend to it. But when again you try to apply that, in the real world, it's not as neat as it was there. So there's a learning curve when you move from academics to professional life of actually implementing these things in the real world, and then you have all these outside influences. The marketplace can change, competition can change, the algorithms themselves, they can change. So you have to be a lot more flexible, I find, in the real world. And the major difference between academic and professional AI, I feel, is that academic AI asks, can we build this system? Is it even possible to? Whereas in banking, we ask, can we trust this system over 5 years under regulatory pressure and fraud pressure, things like that. So it's different incentives. So it's about alignment and what needs to be done.
Oh, love it. Love it. Thank you, guys. Yeah, Miruna, this is excellent. It's really, this is important. So clients, industry, banking, they can, this is still a new area. people are starting to, they're still trying to figure out how you can implement AI in their bank. And this kind of information will help, because what you learn in a university or on an online course is different when you try to apply it in a bank. And like you said, James, or you're trying to figure out a fraud model that will give you a high prediction rate, right? So very interesting. Thank you. So moving on, I have another nice question for you guys. So last month, the administration came up with the Americans AI Action Plan. In that plan, when you read it, there is a good points that are going to be applied in the United States to make sure that AI or the country becomes a first in the AI world. But one of the interesting points that I saw there was the open source and open weight AI. Right? When you go to the cybersecurity side, open source can bring some risks to whoever is applying those open source softwares. But in this case, so I asked both of you, and we're going to start with Miruna again. So what do you think about open source and open weight AI? Is it good? Is it going to be good for industry, for banking? What is your thoughts?
So they can significantly improve the transparency, right? Because we have open source models, but we have a double-edged sword at the same time. We have a positive side where the transparency will allow the regulators, the researchers, the public, right, to probe actually how we end up with some decision, how these decisions are actually made. And of course, that will lead to build this customer trust, to support the compliance. And also it will help banks to identify and correct any maybe false positives that we might have. But at the same time, we do introduce some new vulnerabilities. We can speak about cyber attacks, adversarial manipulation, and just if we think about how the attackers can craft some inputs designed to trick us, right? To trick these models. If they have access to the model architectures, to the parameters, because they are public, then it will be so much easier for them. So yes, I think we should see both cases. Yes, they build trust, but how we could actually avoid these malicious actors, how we could actually improve the security of these models at the same time. What we should do that in that scenario as well.
Thank you, James.
It might surprise you that I don't have $100 million laying around that I can go build my own foundational large language model. You know, these things are incredibly expensive to develop. So when a company like, say, Meta releases Llama 3, it's completely open source. You can see all the weights, you know, you can do your own experimentation, stuff like that. I mean, that's the democratization of knowledge there, which is a very important thing. It's going to keep driving the industry forward, not only large language models, but across just AI in general and tech in general. So open source is a very important concept if we want to keep moving forward and not everything to be just hidden behind some proprietary IP, and copyright laws and stuff like that. The other problem with this, though, is because I have access to it, that means also everybody does, including adversarial, organizations, fraudsters out there and stuff. They have access to these open weights, and then if they can, get their hands on these systems, they'll understand how to exploit these systems, very well. So they can probe for weakness across these large language models. So they have a very good idea of what's fraud techniques or cyber attacks is going to work, before they even go into, try to apply it. So there is an inherent, risk, as part of the open source community, but it's also very necessary. So how do you bring them together? Well, we need to try to find a way to balance, use open models for research, but production, needs like defenses, put in there, and proprietary safeguards.
Thank you. And I agree with you on the inherent piece, the inherent risk comment. Before AI, before 2022, before ChatGPT, open source was a no-no in the banking industry. But let's see how it turned out after AI, right? It might be helpful, or like you said, it might be good for training or understanding what type of attacks can they do in an LLM, for example. But yeah, production would be interesting to see if they can apply or not. So let's stay with you, James. So, you've seen firsthand where model succeeds and when model fail, right? You've been training and developing machine learning model in banking way before ChatGPT came to the world. So let me ask you, man, what's the single biggest AI trend in banking right now that the board should pay attention to, and what is just noise?
I think that the biggest concern right now are these, it seems like whenever we're talking about AI, it's really limited to these large language models because they are like, the most impressive piece of technology that's hit since the invention of the internet, really. You have to think, how transformative this technology is, and it's taken us in a completely different direction. So when we talk about, the biggest threats, obviously, large language models are at the top of the list because we're trying to find ways to safely integrate, this technology into our systems. We want to be able to give people, good chat bot, experiences, or even good, phone representative experiences. There's ways that we can augment, our current systems with LLMs to provide, current, phone operators with maybe some more complete information or a better script or something like that. But it's really up in the air right now of, how these things are going to play out. I would say the biggest, threat in banking right now is not only just adversarial attacks. That's always going to be a problem, but it's even the way that we're using it. And we think that we're providing a service to, our customer base. Well, it can really, lead to maybe some misinformation going out there. These things still kind of hallucinate, even though we've been really trying to find a way to bring those issues in. It's still a possibility. We still hear stories every day about how the model wasn't supposed to do this, but somehow, it did. And because these things get increasingly complex, it's getting increasingly difficult to look into these systems and figure out why it's making these decisions that it is. So as strong as a push there is to keep going and develop these things even further, I think on the actual implementation side from industry, we're having a moment right now where we're trying to decide, is it worth the cost benefit? Is it worth the risk out there to put these things out there? Because there's a lot of reputational risk for the company too. It doesn't matter if you're in banking or if you're in retail or any of these industries. You have a client base. You want to make sure that you maintain that good relationship. And if you have some automated system that may be giving out false information or is open for some kind of adversarial attack, these are things that we really need to be cautious on.
Thank you, man. I agree. We're still finding that place where we don't know what noise is and what is trending, and it's going fast. And all the the new technology agents, the new in ChatGPT we have the new model, the 5.0. So it really, by the time we figure it out, something new comes up, which is also makes it interesting. So Miruna, you are our expert in explainability. So let me ask you, in your experience, right, in academic and industry, in banking, explainability is a big part of what we do when we develop models, not only AI models, any type of model, your risk model, your lending models, right? We need to be able to explain, especially when we do model validations, explainability is also a big piece. So let me ask you, what is the most misused explainability technique in banking today? And what should we replace it with?
So we know that we started to use a lot LIME or Shapley values. So we have these local interpretable model agnostic explanations and also the Shapley additive explanations. And they are considered kind of a silver bullet for explaining these black box models. Large language models or not, we try to actually identify what's happening behind all these models that are coming up with some decisions without even knowing how they work. So these methods, right, they try to provide some local feature level importance, and this sometimes can be mislead or insufficient. And if we think about regulatory compliances or even some genuine understanding of these AI models, we might need to provide a bit more. We need to also understand the model's behavior and any underlying biases. A good example will be here. If we try to do a credit check on one individual, we might come back with a very good response, with a good explanation for that singular person. But we don't know if in these models we have some inherited group biases. We don't know if actually we might decline, for example, that credit for a specific group, if we have specific included biases. Now, why these models are so popular and why are so used in the banking field? Because they are model agnostic. If we have complex models such as neural networks or even a gradient boosting, they are very good, good to explain the information behind these models. But are they stable? That's the main question that maybe we should ask. So their misuse might be also linked to these small changes in the data, in the input data, and how we could end up with a very different explanation with just a very minor change. And of course, this will lead to mistrust. People won't trust these systems anymore. And also we do, as I said previously, we do need to find more information, not just about a singular person, but try to identify some maybe systemic behavior, try to see how actually this model will perform across a wider population. Not even let's start just with a sample and try to see, okay, what's happening in this sample? Can we identify any biases? How we can mitigate them? And maybe we will penalize some specific demographic groups and we don't even realize that. And it's very important, right? When a bank needs to know exactly if we should, for example, provide a loan or not, or even other scenarios. So we do have this illusion of explainability. We don't really explain what's happening behind these models. And with the recent regulations, we have, if I'm correct, the Fair Credit Reporting Act, or even in the European Union, the AI Act, we do need to explain exactly how we end up with a decision, what contributed to an actual decision. Now, a good question maybe will be, what should we do? How we should replace these two methods? I don't think we should replace them. I think we should add even more information. So maybe the bank should also adopt more interpretable models, maybe decision trees, like some models that are considered white box models. We know how they work. We can visualize what's happening behind them, and we can see exactly how we end up with a decision. We can stop at a specific node and we see, okay, this feature actually influenced the output, or maybe not. But if we still want to use that deep learning methods or neural networks, maybe we should also think how to provide the explanations, maybe in a natural language way as well. So we could use natural language as a medium. And here we can come back with these large language models. They might help us to provide explanation for our users, for our customers, and even for the banks. And maybe we should think here about contrafactual explanations. So have some specific facts behind all these decisions. So yes, we have a small change in our data, but actually this led to the outcome, to the final outcome or not. So we will need to be able maybe to query at different stages how we end up with a decision. I'm trying to think here about an example from the bank. So if you have a loan, right, and you need to get it approved, you want to know if your income influenced the final response, maybe 60% or not, and if so, what you can improve, what you should do actually in that case. And according to the new regulations, we are not able just to say you are accepted, yes or no. We do need to provide more information as well. So there are many things that we could do. We should still use Lyman Shapley values, but we also need to add a bit more. As I say, I do propose these contrafactual explanation, natural language explanations.
I like the term that you use, the illusion of explainability. I think that that's a great risk that I don't think that too many people are considering it when they do the risk assessment. and all the techniques that you mentioned will help with that illusion of explainability. Because at some point, when you use, whether you use a decision tree or a random forest, that makes a big change on your explainability. And people are going to be understand the clients, industry, understanding how to really better explain why you use a random forest or not a decision tree. But that's a good point. So back to you, James. Let's get a little bit more deep into fraud and machine learning and banking. So let's talk about synthetic identities. Which three features have been most resilient in your experience or research? And how do you validate their stability across demographic segments? That's very specific to fraud, man.
Yeah. So when we talk about, fraud, especially synthetic identities. So there's lots of different types of fraud, obviously. Synthetic identities is when you're basically making up a fake person. So you might take a child's social security number, maybe a grandmother's birth certificate, and make up a fake name and stuff like that. So you're creating a new person. So this isn't taking over an existing account or anything. Synthetic identity is you're creating a new person, and then this new person's going to apply for loans or try to get a credit card or something, usually around financial fraud. Although it's not always just related directly to like banking. There's fraud even in education. So you might get student loans for a student that doesn't exist. It could be in government where you're getting a government benefits or services for a person that doesn't exist, something like that. So synthetic identity is a certain type of fraud there. And the way that we kind of like, at least the first level of combating this is looking at, say, history, first level identification or verification of identity, and kind of like a first level verification of the device and location. So for history, we look at things like, say, your credit bureau file. You have a thick file or a thin file. What this means, a thin file means, is you really have no credit history at all. So this might be the first time that you're applying for a credit card or a car loan or something like that. So synthetic identities will generally have a very thin file because they're not real. They haven't been around. They haven't had time to really develop all this information. So now the best fraudsters out there will create these synthetic identities and treat them legitimately and let them mature so that they actually have a good credit history. So then they can make the big score, as we say, then they're going to go out and try to get a new boat or a Porsche or something like that, that's a high dollar item. You can't do that with just a thin file. So that's why, you have to let these things mature and so that they can get more than just a very low level, maybe introductory credit card or something like that. So looking at their history from a credit bureau thickness of their file is one way that we can like kind of do a first pass, is this a synthetic identity? But it could also be like, maybe it's not complete, because it could be just a student, someone who does have, they're kind of new to the the credit, industry. It could be someone who's just coming into this country. So they might have had lots of, credit established elsewhere, but you come over here, and it might not be recognized. So that's not just a tell-all for all cases there. The other way that we can like identify synthetic identity is looking at just a first level verification of identity. So we'll look at, like, say, the social security number, the issue date, versus the date of birth on like a birth certificate. Is it plausible that, they're within the same, time, things like that. So we have, it's kind of like maybe a ham-handed, maybe not like very, high tech, way of doing it, that kind of thing. It's more of a rules-based approach. But we can also look at like, at the device and location, we could cross-link analysis across emails and phones and addresses and just kind of like try to check and stuff like that. But, synthetic identities, they're actually more difficult to identify and combat against than you would think, just because the best people out there that are doing like the fraud of it, like I said, they let these things mature so that they look like legitimate, customers looking for legitimate loans.
Thank you, man. And what I'm gonna be asking you to also about account takeovers too, because that's also a big type of fraud that
Sure.
the banks are looking at. But let me go with Miruna, okay?
Mhm.
And then we come back, James, to you. Miruna, going back to explainability. When do you
Yes.
think when do you recommend we need full explainability for a model in banking? And when, no, when do you think we do not need the full explainability, and when do you think is non-negotiable?
Well, of course, full explainability is not always needed. It will depend on the impact and the purpose of the AI decision. And very good examples here, of course, are the fraud triage or credit denial. So there are different scenarios. For the fraud triage, we do need full explainability, or for the credit denial, might be non-negotiable, because we really need to explain how we end up with a decision there. So I think it's very important to set up now the goal of these examples, that we make it even clearer. So if we speak about the fraud triage, we have an AI system that will look for different factors and try to locate if a transaction is fraudulent or not. And of course, that will flag it to the actual user, and the user actually will have their own permission, like they could actually provide their own, let's say, feedback to say, okay, this is actually fraudulent, or this is myself, I can still continue to do this specific task. But if we think about the actual AI decision, the customer won't be actually affected directly by this AI decision. It's just a measure of protection, try to protect actually the human as well, and it just prioritize alerts. And in this case, of course, is not a priority. We don't really need to explain exactly why we end up to actually select this as fraudulent or not. Now, of course, there are some specific things that we should consider. Maybe we should consider a high volume of fraudulent behaviors, fraudulent threats. So fraud detection systems can process millions of transactions or even more, right, per second. But they will require that human understandable explanations as well. And if we want, of course, to advance our AI system, we need to consider this as well. Maybe we should also consider some security risks, try to provide that detailed explanation for every flag transaction, but this will take a bit too much time, and we will end up maybe with a transparency paradox here, where we try to give the fraudster a roadmap to the reverse engineer part of our system, and we can kind of help them as well. So no, definitely for this scenario, we might not need an explanation. But if we speak about credit denial, that's extremely important. It will negatively affect actually the person, their application, and explainability now, it will be a legal and ethical requirement. Because we even have law for this. We have the Credit Opportunity Act actually in US, and GDPR in European Union, where we have the right to explanation. So it will require, right? It will be a must for the financial institutions to provide a clear reason for their denial. I actually said previously that you are not able nowadays to just say the algorithm said no and that's it. You need to have actually sufficient reasons for why we end up with a solution. And again, we need to think about the trust and fairness of these AI systems as well. And we need to make our applicants to understand how they can actually improve their own credit score, how they could actually get access to all this. So there are many other things to consider. Let's say that, so overall, we don't need always explainability, but we need to be very careful on our AI system purposes, our own AI system goals. Yes, so I think I replied to your question, Alejandro.
Yeah, and I like you also use another term that I like, the transparency paradox. That's an interesting one. That also, I think that we should put it in our risk register as one that has to be looked up, watch for.
If I could jump in for a second there,
yeah, go ahead.
She made a great point about, explainability, especially when you're, say, denying, a credit application or something like that. You can't, because part of federal requirement is that we would need to send, a person who applied who got denied a letter that explains why, and that letter can't be, well, you achieved a certain threshold or, fraud detection or denial detection or whatever. You need to be able to explain this stuff in terms that people can understand. And that's kind of the real problem that a lot of places are dealing with right now. in that, we're using these very sophisticated models to try to do underwriting, determine, should we give this person a credit card or not. But then when we make that decision, we need to be able to explain it to them in a way that, the average person can understand. And most people don't understand, well, for our, XG boost model, you hit a predicted probability of a 0.75, and that's above our threshold. That doesn't mean anything to my mom, who's going to get rejected from a credit card. So we need to take all this big information and boil it down to a story that people can understand.
It's a very good point here, James. In a very different industry, I actually had the same problem with the extreme boosting classifier, where I just ended up with some scores, and nobody from our team actually trusted that scores, that responses, and they are like, okay, explain me this. So actually, this led to my research in explainable AI field.
Yeah.
My whole journey. Yes.
Nice.
Yeah, explainability is a big, especially in AI, it's a big topic. Whether it's banking, health, whatever it is, you need to explain it. So moving on, let's do. This is a question for both of you. Let's say we're familiar with NIST AI Risk Management Framework 1.0. It came out, I think, a year ago, 2 years ago, and it's a nice framework as a guidance, right? So if that would be mandatory tomorrow, which single control you would implement first in a bank, and which one do you think is over-indexed in the bank? Let's start with you, James, on that one.
It's hard to say because I think, it varies, between industries, obviously, and, the banks and stuff. When I think about, what controls can be put in place, for AI, what we really rely on, kind of are these like benchmarking, dashboards, kind of stuff like that. So we can really keep an eye in real time of what's going on, not only, with fraud, but in every aspect, of AI, with our underwriting models. So obviously underwriting models are one of the key risk factors for any bank, because that's where all of your risk lies. Are we giving, credit to people who are credit worthy, that kind of stuff. So even though we have a lot of sophisticated tools, Maruna, talked about, SHAP and LIME and all these like statistical techniques that we can try to look in and understand what these variables are doing. Oftentimes, the more effective approach is just a good, monitoring dashboard where you can see, just historic trends and like new events that are happening. We have techniques that we use where we identify, an issue before we even really understand what the issue is. For example, in fraud, we use something called isolation forest. And this is a great technique, either that or auto encoders. These are great techniques to try to identify like new fraud techniques that we don't even know what's going on. Only thing we know is that these transactions are different than everything else. So we're not even worried about explainability at that point. It's more just a safety protocol for us. So we need to be able to just separate out these transactions look different than everything else, and let's take a second look at them. Sometimes you got to put a set of human eyes on this stuff in order to understand, there's a new technique that's happening out there. We don't even understand what it is, but we need to start to question some of these transactions. So this might be a little bit off topic from the original question, but when I try to think about like safety and protocols in financial services, a lot of times we're relying on older techniques like just simple thresholds and dashboards.
Good point. And you also mentioned the human eye. We need it. We still need that human piece making that decision and understanding what's happening and tuning the model or tuning the results. So, Miruna, what would be the control for you that is that we need to have that from that NIST framework, and the ones that you think is overrated?
I was thinking a lot about something very similar, how we could actually get control in general and try to measure all these things as well, how we could actually control the AI risk or AI risks as a plural. So we need first maybe to think about who will be responsible for some specific AI risk. We don't have that clear ownership, and I think we maybe should consider governance. Try to see in specific situations who will be actually the leader, who will coordinate different standards, different steps. It might be the data science team, it might be the IT, legal team. So I think it's very important to provide the right roles for everyone and make that you are responsible for this. Let's see next. What's the main risk that we should assign to all this? And I think in the banks, actually, we should also know how much risk they are willing to accept from the government as well from themselves. So how we will compare maybe an AI fraud detection system with maybe a very catastrophic risk when a model will make the wrong decisions. So I think we should also structure the levels of risk we assign to different AI models. I think there are so many problems actually that we should add here as well. So governance should be the first. And what is the most indexed? Everyone focus on explainability. You just mentioned Aleman. Yes.
Yes.
So it's quite visible. Everyone speaks about explainable, interpretable. We don't really know even how to identify what makes responsible AI till this point. On what exactly we should focus on that why questions or how questions. So why we end up with a decision or how we ended up, what's happening behind. And of course, we come back with that tools that I mentioned, the SHAP and the LIME methods. Like we do need some robust explanations for the whole AI model. And we also we started just focusing on the explainability and interpretability to avoid, or maybe not to avoid, but to neglect our other risks that we might have, even that adversarial effects that there are so many things that we should consider. And I think we should make a very clear structure for all these things as well. So adversarial attacks, data drift, model drift. Let's be honest, if we collect some data and we just do our own data quality, we won't spend the time to re-update it, try to check it up. So we need to be also very careful with that. Yes, so I think these are my thoughts. It's quite a difficult actually question. It's very hard to reply correctly to it.
Yeah. Oh, it has many answers because it also will depend on what management, senior management looking for or the industry. But I think I will stay with what you both agree on, which is even though we're talking about AI, which is it could be something technical, you both refers to governance. You mentioned it, governance, Miruna, and James, you mentioned your all good fashion dashboard, which is reporting, right? Is at the end is the governance piece. And that's interesting because even though we're talking about something technical, what you mentioned, you can have data drift, model drift, you have all those statistical models. At the end, if you're, how you monitor, you have the policies, you have the reporting, you have that governance piece in place. So interesting. James.
I got to say that I'm jealous of Maruna's skill set and her specialty because explainability is going to be the biggest thing that we need to focus on in the next 10 years. So my suggestion for anyone who's like entering the field of artificial intelligence or data science, explainability would be a key thing to focus on because not only are the large language models, like the companies that develop these, they need that component, but every industry that's looking to implement these as part of their standard business practice, we need to be able to explain what's going on, and it's very difficult. As these things grow in scale, you got to think the latest Chat GPT model, I think it has 1 million nodes and like 1,000 hidden layers, and there's no way to know, that you can say definitively exactly what's going on because it just all gets averaged together and stuff like that. So Maroon has got her, work cut out for her, I think, to try to make heads or tails of, what's going on with a lot of these, especially in development and in implementation.
Oh, yeah, and the validation piece too. And when we do, we've seen in our clients, the regulators starting to go in details into how the AI models are being validated, and explainability is a big part of it. It's a big portion of what they're looking for. But James, let's switch a little bit. We worked together in proposal for a client that was looking for do a pen test for a AI. right? Implementing an AI model, especially Gemini, into their bank. So, what would be your playbook for those type of adversarial attacks in a chatbot or an LLM model in a bank?
Well, yeah, I think the best approach is to have what's called a purple team drill. So usually you have a red team, which are like a set of attackers, and oftentimes these work independently. So you can hire a red team to come in and just try to, adversarially attack your system just to test to see how it is. There's companies that specialize in this, and you also have, of course, the blue team. And so these are the defenders. These are people who's trying to, provide defensive tactics to make sure that, malicious actors don't get their hands on bad data, get their hands on data or anything like that. So, but the approach that we work with, internally, is more like what we call them purple team drills. So both these working together, they're working separately, but they're working at the same time. And they know about each other. So this way that, it's fraudsters probing, say model boundaries with adversarial prompts and synthetic profiles. And from the firm's perspective, we know that these attacks are happening. How can we, monitor them in real time and defend against them in real time? Prompt injection is such a new thing now that there's not even courses taught on it yet, in academia. So it's things that we're just trying to get our hands around and develop now. Unfortunately, a lot of the real groundbreaking work is coming from the fraudsters themselves. I mean, they're very inventive people. I got to give it to them. The prompt injections are many things that I would have never thought of, like ways to attack things. In fact, I just seen a very interesting example. Now that we're moving over to more of an agentic workflow. A red team company, I think they're called Brave or something like that. What they found is if they hide some information on their web page, and it would be like a command prompt, buried in the web page. Once one of these agents goes and they read in that information, it could then trigger that command prompt to then either give the fraudsters access or critical information or user history or chat from other people, stuff like that. So the best thing that I think we found is to work, to do a purple team drill where you have attackers and defenders, working within the same system. And this is the only way that we can learn is by, basically, you have to do your practice. Just like a football team or a baseball team, you need to practice before you go live into the game.
Thank you, man. That's interesting what you mentioned about that prompt attack in putting a website. That's, it's incredible how these guys can find a way to try to attack, man, and compromise. Yeah,
it really is.
It's crazy. Yeah. So we have 6 minutes left. This time goes by really fast, especially when you're talking with the smart people like you guys. So in 6 minutes, let's try to do some conclusion. I want to wrap up what you guys mentioned. You have plenty of more to say, but time is running out right now. But so let's start with Miruna. So Miruna, if you can provide 3 recommendations, take away, especially for community banks or mid-sized banks, right? What would you say when you have the board and senior management talking about AI, how they can implement it? What would be the best way, the best route? What can they do?
There are so many things that they have to do, but I think they should start small. Think about clear scenarios that are actually built for real impact. So they should think about real-time, maybe transaction streams. Try to create these models for real-time data. And then they should also think about how to measure the business benefits, matters to customers as well. And of course, thinking about the previous guidelines. Try to think how they should actually measure the AI systems, fairness, explainability, alignment, all these are important. So now we jump, the second one will be to prioritize explainability and trust. We do need trust in order for making our customers happy, our users happy, and build that confidence in AI. And something that it wasn't really discussed today, maybe the continuous feedback loop. We do need the human help as well. We do need their feedback to retrain models, to provide some insights. Let's not even speak about the retraining a model, but actually to know what we should expect from an AI model. So these are the 3 things that I think are important. Start small, explainability, and continuous feedback. Yes.
Thank you. James, if you can add also in your recommendation, James, some comments for the
Sure.
account takeover piece when you do the fraud models.
So, I completely agree with Maruna's, assessment there. I would say, especially for community banks. So that's what, you talked about. Community banks generally, they don't have the resources that they much larger like a Wells Fargo or a Chase Bank has, stuff like that. So my recommendation to a community bank was first start simple. So if you have nothing in place right now, it's okay to start with a logistic regression model or a simple decision tree, just to start to understand the data and to use just business rules. So this might be like a little ham-handed, approach, simple models, business rules, and then you're just going to add the advanced AI gradually. So you need to have something in place that it works first, and then kind of build on it from there. The other thing, the part two to that, the next part, would be like to invest in monitoring. So it's not enough just to set it and forget it and just assume these systems are working. You just don't want to deploy. You want to watch for drift. You want to watch for fairness. You want to watch for latency. You want to watch for change in behavior of certain organizations or actors, things like that might be trying to counteract what you're doing. So the first thing is to start simple. The second thing is to invest in monitoring, and the third thing is that especially when we're talking about fraud, it's a team sport. So it's not just like you have just the fraud, the people, who try to monitor it and that's it. No, you got to train fraud and data science and risk teams and cybersecurity. All this needs to be working in concert with one another. Now, you'd mentioned like account takeover. Now, obviously, we have systems set up, in my bank, I bank with JP Morgan, and they know a lot about me just from my transaction pattern. So they know if they see a transaction that's going to occur at 3:00 in the morning, and it's for a Chanel bag in Dubai or something. They probably know that's not James. I'm not a world traveler who's going to buy Chanel bags at 3:00 in the morning that are $5,000 a pop or something like that. So just taking this general information that we know over a transaction pattern, Chase knows that James is an old man. He's probably in bed by midnight, and he's never bought a Chanel bag in his life, and especially these large dollar items, stuff like that. So there's ways that we can just apply simple rules and storytelling, especially for fraud, but we combine that with some dashboards and some starting with simple models and maybe increasing the sophistication until we feel like we really have our hands around it. The worst thing I think that the community bank can do is try to implement some very sophisticated, complex fraud management structure or something like that when they don't even understand how it works. So it's important to understand from the ground up how these systems work and to continuously monitor.
James, Miruna, James, thank you very much from the bottom of my heart. Really appreciate your sharing your time, sharing your knowledge. I'm very excited about this podcast. I'm very excited about working with you guys. I'm excited about you joining us and helping our clients in this new trend with innovation and technology, which is implementing and helping clients use AI. And risk and cyber, you guys help with more than just the AI piece, but I really want to thank you. It's 11 o'clock, so we need to close the podcast. It was great. If you like it, the audience, you know the drill. You need to subscribe, like, and share. Help us spread the good word and knowledge that these two incredible professionals bring to the table. And thank you again. Appreciate your time. Hope you have a great day.